Welcome to this explainer. Pull up a chair. Today we're putting on our senior developer hats, and I'm going to mentor you through one of the absolute most critical, yet somehow completely overlooked skills in modern AI-assisted engineering. We are going to cut your Claude Code API bills right down to size. Look, as a junior developer starting to use these incredible agentic tools, it is just incredibly easy to treat the AI like magic, right? You just kind of ignore the underlying architecture. But in the real world, efficiency matters just as much as writing good code.
All right, let's dive right into this exact pain point. Have you ever fired up a new terminal, opened Claude Code, and realized, with a sinking feeling, that you just burned 40,000 tokens before you even typed a single line of logic? I mean, why let Claude do that every single time you open a session? These are classic rookie mistakes, letting the AI blindly read massive hidden files or totally unnecessary directories. It just burns through massive token limits, and it takes your budget right along with it.
So here is our code review roadmap for today. We'll start with token savings for juniors, then hit Strategy 1, code indexing, Strategy 2, compressing logs, Strategy 3, caveman mode, built-in session management, and finally wrap up with the quality trade-off.
Let's kick things off with Section 1, Token Savings for Juniors. As your virtual mentor today, I really want to drill a specific mindset into you, understanding cost efficiency. That is exactly what separates the novices from the pros. Pretty much anybody can prompt an AI to write a script these days, but a senior engineer actually understands system design, resource management, and how to operate these agentic loops at scale without completely breaking the bank. And we aren't just talking about shaving off a few pennies here. We are talking about a 90% reduction in token usage. By setting up the free open-source strategies we're looking at today, you can use a fraction of the context window to achieve the exact same, or honestly even better results.
Moving right along to Section 2, Strategy 1, Code Indexing. So, we're going to be using an awesome open-source tool called CodeGraph. Think of it kind of like how Google maps out and indexes keywords so you can search the web instantly. Well, we want to do the exact same thing for our local codebase. A standard junior setup basically lets Claude do a basic grep, reading files one by one, scanning through tons of unused code just to find one single function. It is painfully slow and it's super expensive. But a natural language graph uses a pre-mapped index. Through semantic queries, Claude can literally skip the junk files entirely because it already knows the map.
Now, getting this set up in your terminal is crucial, so let's walk through the commands. Step 1, you'll install the library using an npx command, or you can just install it via npm global. Step 2, you initialize your project right there in the root directory by running codegraph init-i. And step 3, you can actually verify everything is working smoothly by running codegraph status. That'll show you the metadata, the nodes, and all the imports it mapped. The real beauty of this is that Claude Code automatically learns how to use this CLI tool under the hood, and it will leverage those pre-indexed queries completely on your behalf.
But let me drop some senior-level wisdom on you here. There is always a trade-off. By indexing, you now have two sources of truth, your actual code and the index itself. We like to call this the syncing tax. If you forget to sync your code graph after a really long coding session, the index gets stale, and then Claude will confidently hallucinate that a file or a function exists when you've already deleted it hours ago. Secondly, you definitely risk accuracy drops. If you have big compound module files, like say a deeply nested cloud.md file holding critical context, a targeted semantic search might just skip right past it.
All right, Section 3, Strategy 2, Compressing Logs.
If you've been programming for any amount of time, you know that NPM and server logs are just incredibly noisy. That massive, terrifying wall of standard errors and warnings gets completely swallowed by Claude, and it just eats up tokens for information it doesn't even need to see. But if we use an open-source library called RTK to intercept and compress that CLI output, it changes the game entirely. Instead of feeding it 1,000 lines of test paths, it simply tells Claude, 43 test paths omitted. It bundles up the warnings and just trims the fat completely.
Setting this up is an absolute breeze. Step 1, just use Homebrew to install it right onto your machine. Literally just a simple brew install command. Step 2, you can choose to install it globally or just keep it localized to a specific directory. And step 3, just run your standard commands. Claude Code is actually incredibly good at juggling CLI proxies, and as a quick side note here, a lot of developers are realizing right now that standard CLIs are vastly superior to MCPs or model context protocols for these specific types of compression tasks.
However, just like with our index graph, I've got to warn you about the trade-offs. Compression is inherently lossy. When you aggressively squish your logs down, you have a very real chance of dropping a highly specific debug message or system log that you were desperately looking for. As you grow into a senior role, the skill isn't just knowing how to use the tool, it's knowing exactly when to turn it off. If you're deep in a self-healing debugging session where the agent really needs to self-correct step by step, do yourself a favor and turn RTK off.
Next up, Section 4, Strategy 3, Caveman Mode.
Okay, this strategy definitely has the most aggressive name out of all the open source libraries we're looking at today. The core premise is delightfully simple: getting Claude Code to just talk less. You remember Kevin from The Office? Why waste time, say lot word when few word do trick? Kevin was truly ahead of his time. He was the original Claude Code maxer. Caveman simply shortens the amount of words the AI uses to deliver the exact same information.
So, how do we install Caveman? It's just as easy as the others. Step 1. Run npm install for the Caveman package directly in your bash terminal. Step 2. You actively set the library's mode on a per-session basis. You can choose light, full, or my personal favorite, ultra mode. Step 3. You just run your prompts. So when you ask Claude to describe the project, instead of a massive multi-paragraph essay, you are going to receive about half the output length with the exact same level of accuracy.
But we do need to have a pretty serious talk about the risk here. When you aggressively trim AI outputs using something like Caveman Ultra Mode, you risk context window degradation over time. Remember, the agentic loop relies heavily on its own message history to maintain context. If you shrink those outputs down too much, the feedback loop for long-running sessions starts to degrade, and that puts the entire correctness of your codebase at risk. The AI simply forgets important details because, well, it wasn't allowed to write them down in its own history.
Moving into Section 5, Built-in Session Management. We've talked a lot about fancy open-source libraries, but honestly, sometimes the most powerful tools are the unglamorous native commands provided right out of the box. Proper session management is absolutely fundamental to keeping your context lean. Here are the vital / commands you need to memorize right now. Use /compact to debug your current context usage. Remember earlier when I mentioned burning 40,000 tokens instantly? Yeah, often that's because you have a massive hidden cloud.md file draining 4% of your tokens every single time you hit enter. /compact lets you audit that. Next, use /clear to wipe the context completely when you start a brand new task. And finally, /model to switch AI engines right on the fly.
A really core strategy here is understanding that you absolutely do not need to be on the most expensive, top-tier model 100% of the time. Use a much faster, cheaper model like Haiku when you just need the agent to navigate Chrome. Use Sonnet for scheduling jobs, or repeated scripts, like, say, a script that cleans up your desktop folders. But when it comes to deep, complex programming and system design, that is when you swap back to the top-tier, reliable models. The quality itself becomes a token saver because it gets it right the first time.
And finally, Section 6, the quality trade-off. This is where we bring all this mentorship advice together. Because, saving tokens is fantastic, but development efficiency is really about balancing that cost against the actual quality of the software you're shipping. So here is the crucial rule before you even type a command. Always use plan mode first. Never let Claude just guess and write code blindly. If you are starting a new feature, go into Pencil or Figma and design it first. Run off those designs and use plan mode to build an architecture. Getting Claude to write code blindly, failing, and then rewriting it over and over burns far more tokens than just planning it correctly from minute 1.
Ultimately, this is the core senior developer lesson you need to take away today. Every single tool we discussed, CodeGraph, RTK compression, Caveman mode, they all add a layer of complexity. You're introducing multiple failure points that you now have to juggle: a stale index, a dropped log, an over-trimmed context window. You are constantly balancing the cost of API usage against the quality and accuracy of the code being generated.
So, I want to leave you with this final thought as you head back to your terminal today. Slashing your token usage by 90% is incredible for sure, but are those massive token savings actually worth the added complexity to your workflow? Understanding exactly when to apply these tools, and maybe more importantly, when to turn them off, is what will truly make you a master of agentic coding. Thank you so much for joining me for this explainer, and I will see you on the next one.